Hello everyone, and welcome. Thank you for joining us this afternoon. So for those of you who don't know me, my name's Helen Spiers, and I've been organising this webinar series as part of the efforts of CCP-volumeEM. We also have Martin Jones here on the call as co-host, and he's the PI of CCP-volumeEM. So this is the second webinar in our show and tell series, and today we're very pleased to welcome Dr. Kimberly Meechan, who will be speaking about good practices for image analysis software. So Dr. Meechan is a research software engineer at UCL's Advanced Research Computing Center, specializing in image analysis software. She has contributed to a range of open source projects, including Crosshair, Moby, and BrainGlobe. She has a PhD from EMBL, focusing on volume electron microscopy data, and she has completed a postdoc at the British Museum, focusing on X-ray CT and 3D scans. She's a maintainer of the Data Carpentry Image Processing with Python course and regularly teaches Python and napari courses at UCL. So in today's talk, Kimberly will be discussing some of the software practices that can help make image analysis tools more robust and easier to maintain over time. So we're looking forward to that talk today. We'll leave some time for questions at the end, so please add them in the Q&A tab as we go along. And just to note, this session will be recorded and will likely be shared on the CCP-volumeEM YouTube channel. So with that, I'll hand over to Kimberly, and thank you again for joining us.
Great. And yeah, thanks very much for that introduction. I will find my slides. Let me share this one. And it'll swap over. All right. Hopefully that is all good. All right. Yeah, so quick summary of this, but you all kind of heard it now as well, just to say, yeah, I'm a research software engineer. So in case some of you aren't familiar with the term, it means that I write software for and also in collaboration with researchers at a university, in this case at UCL. I'm in their Advanced Research Computing Center, which you can kind of think of like a software core facility almost. Different researchers at the university can submit projects to us, and then we work together with them to make the software that they need for their research. We work on all sorts of stuff, so biological, medical, and lots of imaging related, hence why I'm talking today. And like we said in the intro, I contribute to a lot of different open source projects, so things like Crosshair and Moby. And as part of my current job, I contribute to all sorts of different ones, things like BrainGlobe, which was also Python and napari based, made by the neuroinformatics unit at Sainsbury Wellcome Center. And I'm going to be sort of talking about a few examples from these different projects as I go through. So yeah, the main focus of this is around software maintenance. So I wanted to give a bit of an intro about why it's important, what kind of changes might be made, because I feel like we might have quite a mix of people in the audience, like some people who have done loads of software and some people who are maybe just starting to dabble with it. So as I say on the slide here, software needs continued work to remain up to date. So I feel like, especially in academia, we tend to have this focus on the very first step, which is getting the software to do the thing that it needs to do, to do the image processing task, etc., getting the paper out about it, and then that tends to be the end of the focus there. But it's not really how software works in the real world. A lot less time and funding is given to the long-term work that's needed to keep software running, to keep it up to date, to keep it relevant, etc. And all of that extra work that goes beyond just getting it to do the thing it's supposed to do is really important as well. So what kind of things go into software maintenance is things like bug fixes. So when you release a piece of software, there will always be particular things that are wrong with it. Or, maybe you've made it for a specific kind of imaging data, someone tries it with a different type, and now some changes need to be made. It might be adding new features. Again, with that example I just said, often you make it for one specific kind of data, and then people start using it with different kinds. You might need to update things, add extra features for that. It's not all code changes. So things like the documentation that explain how to use your software and how it works. A lot of time and effort goes into updating that and expanding that as well. And even if you're someone who thinks, I'm happy with how my software works, there aren't any bugs. There will be some bugs, but there aren't any bugs, and I don't want to add anything. You will probably still need to do some maintenance work. And that's because, in the modern day, when you write a piece of software, it's really unusual that you're going to be writing absolutely every single line of code that's needed for it, because there is so much code out there now that is free and openly available and incredibly useful and performant that it makes sense to build on top of what other people have written. And everything that you build on top of is usually called a dependency in software. So, my software might depend on some other packages for working with tabular data or for working with some specific kind of statistics or etc. And if those packages get updated, if I want to benefit from those changes and those improvements, it's likely that I'll need to update my package as well. So that's also comes into maintenance. You can also think of the platform that you're building on, something like Napari or Fiji, which are two very popular image processing tools, as another dependency. So, for example, if Napari change how their plugin system works, then I need to update my plugin to let people use the latest version. Again, this is all maintenance time. And even if you think, okay, I want to keep my software as it is and I can keep the same version of all of my dependencies, if you want your piece of software to be used in conjunction with other pieces of software, so someone wants to, do some analysis here and then swap to another tool and then another tool and have them all together, then you have to make sure that your dependencies are compatible with each other. And it's likely if there's updates over here that you'll have to do some updates in yours to make sure that everything can work together. So again, just to say, almost all software needs continued work to stay up to date, to keep it relevant, to keep it functional, etc. And that's kind of everything that goes into maintenance. A bit about the how of how this is done. I want to talk about some of the constraints here. So often when we're working in academia and in science, we're dealing with very limited resources for doing this. So it's often very small teams. It might even be a single PhD student or a single postdoc that is maintaining something that they have written. There's often very limited funding for this. There's a lot more funding around for building the thing in the first place, but there's not a lot of funding around for, keeping it updated, keeping it moving, adding new things. So under these kinds of constraints, we want to try and make all of these maintenance tasks as efficient as possible. We want to make our developers' lives as easy as possible as well. So yeah, this is what the talk's going to focus on. It's kind of all of the steps beyond making the software do the thing it's supposed to do. It's everything around what can you add to make it easier to update, to add things, to maintain it long term, etc. All right. As part of this, I'm going to touch on a lot of different aspects. The idea here is really to give you suggestions of different tools that I have found useful and interesting for this, give you a few examples, point you towards some further resources, but I'm not going to go deep into any of them. And I know that that might be a bit overwhelming because I'm going to introduce lots and lots of different tools, but the thing I want to say is don't feel like you have to add all of these things at once into your project. You can really focus on what is going to have the most impact for your specific project. And I'll give some examples later on, but yeah, it's going to be a bit of a whistle-stop tour through many different things, but hopefully there are some aspects in there that will be useful for your projects. All right, before I get into the main thing, I wanted to very briefly mention Git and GitHub because, again, I think we have a mix of people. Some people will use this every day. Some people might have dabbled with this a little bit, but all of the other tools I'm going to mention build on the assumption that you're using this. So I'll very briefly mention what these are. So Git is a version control system. It lets you keep track of all of the tiny changes that you're making to your code over time, and it tracks it over the whole lifetime of the project. So what's good about this is you have a great record, but also if you ever encounter an issue or make a mistake or want to go back, you can go back to any of those previous points in time. So it's really useful, and you should be using something like this for all of your projects. GitHub is slightly different. It is a website that integrates with Git, and it also lets you collaborate and share your code with other people. You might have heard of other options, things like GitLab, Bitbucket, etc. They're all fine. They all have very similar functionalities. But again, it's good to use one of these so that you're having this version control. You can check where you want to go, but also, yeah, you can share and also collaborate with other people. I will very briefly show you what the Napari GitHub looks like because we're going to be looking at a bunch of examples. So if you haven't seen GitHub, this is what an example repository looks like. This is Napari, which is a popular Python-based image processing tool. And here, again, don't worry about the details, but this is where all the code is. It's free, it's openly available, everyone can browse all of the source code here. There's also a bunch of documentation about how to use it, how to install it, etc. And like I was saying, it integrates with Git. So if I come over here and wait for my Wi-Fi to load, you'll see this long, long list of changes. So every box here is a little change that someone has made to the code that Git is keeping track of. Every time someone makes a change, they give it a brief description. So like here, this person updated the box and the position of some text overlay, but they have a record of that change. And you can kind of think of each of these like a save point that is being created, and you can go back in time to any single one of those, which is really useful. All right, very briefly for two other tabs, because they're going to come up later with specific tools. There's this issues tab here, which every code repository in GitHub is going to have. This is where people can report issues that they encounter with the code, so bugs, etc., and also where they can request features, so new things that they want added. So to pick a random one, this person is asking to add new things to Napari's shape layer. They put a general description, and then they can chat with the developers and they can think about whether they want to add that or not. So issues, very good place to catch, to collect bug reports and also feature requests. And the final one I'm going to mention, I'm not going to go deep into it, but I'm going to be mentioning it multiple times. So just so everyone's on the same page, there's this pull request tab here. And every line here you can think of as either one of the developers or somebody external has written some code and they are asking for that to get put back into the main code base. So I don't know, this person here, maybe they have changed something to the canvas, they've written the code, and now they're saying, hey, developers, can you put this into Napari, into the main bit of Napari? There's more to it, but I'm going to be showing some examples, and hopefully that gives you a brief idea of what these different pieces are going to be. Again, the upshot of this is use Git, use GitHub or something similar. They are really, really useful for code projects. Okay, so now getting into the actual different tools that can be useful on the maintenance side of things. The first thing I want to talk about is dependency updates. So as I was saying in the intro, when you write a piece of software, it's likely you're going to be depending on lots of different packages that do different things that other people have written. This is great. It's good practice to do that. We don't want to be rewriting the same thing again and again. But the challenge is, how do I know when a new version comes out of those specific packages? You know, I might be depending on 20 or 30 different ones, and you know, I could follow their mailing lists and follow them on Blue Sky and whatever, but it's a huge pain and keeping up to date can be really challenging. Ideally, we want to do this automatically, and there are great tools out there to do this. So these tools can detect when there is a change in a dependency, so when a version has changed, and it will automatically open a PR, which is a pull request, which is what I just mentioned, like a little request to add those changes back into the code. This all happens automatically. You don't have to do anything for it, which is great. There are a lot of different tools for this. The two most popular ones are Dependabot, which you can see on the side there, and also Renovate. So I think Dependabot is made by the people who make GitHub, and Renovate is made by Mend. They have similar functionalities. With very broad strokes, I'd say Dependabot tends to be faster and easier to set up, probably, especially if you're using GitHub. But Renovate is more fully featured and it's more flexible. So they're both good options. Some of it is personal preference, which one you use here. All right, the other thing they can do is they can detect security vulnerabilities. So if you're depending on something and a specific version had an issue with security, it will tell you, and then you'll know, okay, I need to update, and I need to update as soon as possible. They work with everything. So they work with Python, which is what Napari is based on. They work with Java, which is what Fiji is based on, and every other language that you can imagine. All right, very quick example. I'm just going to show you a couple of examples where it's used. Let's use Napari because I know that they use Dependabot at least for certain things. So if you go under .github, yeah, here it is. They have this dependabot.yaml file. Don't worry about the details of what is in there. Both of these tools have great documentation, so you can look through those if you're interested in setting this up. The main point I want to make here is you have a file like this, which is the settings for Dependabot. So this tells Dependabot, what should I update? When should I update it, etc. And then Dependabot will sit in the background, monitoring all of your dependencies. And when there's an update, it will automatically open a pull request. So let me try and find a pull request from Dependabot. Yeah, you can see I already did this. if I search for that, yeah, so this would be an example. So this is from 2 weeks ago. You can see that Dependabot has automatically made this. Developers haven't had to do anything. And it's telling it, okay, I have 3 different things that I want to update. And for example, this thing, don't worry about what it is. I want to update it from version 6 to version 7, or this one from version 7 to version 8, and so on. So it does it automatically, gives you a nice description, and it also suggests where you have to make those changes in the actual code. Again, don't worry too much about the details here, but for example, here it's updating it from version 6 to version 7, and this is all directly there. Then I can come in, I can look at this, I can make whatever changes I want to make, I can merge it, and all of this is way faster than doing this manually. Quick example from the Fiji side of things, because that was napari. This is Crosshair, which is a plugin I maintain, which is in Fiji. I use Renovate, and it's really, really similar how it's set up. So you have a settings file called renovate.json. Again, don't worry too much about the details of how this is set up. There's great documentation out there. But this tells it what to update, when to update it. And then when it detects a change, it opens a pull request for me, like this one. And here it's telling me, okay, I see that the POM-SCI Java, which is all of the Fiji-specific dependencies, has updated to version 44, for example. And again, it gives me a nice description, and it also suggests where I need to change things inside of my code. So this seems like a reasonably simple thing, but I would say it does really, really speed up maintenance, because now rather than having to manually figure out, do I need to update this? Do I need to update that? It all happens automatically for you directly, which is great. Okay, one other thing is there are some guidelines for what dependencies you should support and for what versions, and for how long. So for example, for Python, there is something known as spec 0. I'm not gonna have time to go into it, but if you Google Python spec 0, do go have a look at it if you're doing a Python project. This gives examples of the core Python packages, if you use Python, things like NumPy, SciPy, etc., and recommendations for how long you should support different versions. The reason this is good is it's like I was saying at the beginning, it helps different Python packages to work together because they're all depending on the same things. So take a look at that if you're using Python for your projects. Okay, so another aspect is, let's say Renovate or Dependabot, they've opened a pull request and they say, I want to update the versions of all of these things. The challenge with that is there's now no way for me to know whether that will break anything in my code. The way I'd have to check is I'd have to download those versions, build my software, and then do a bunch of manual checks. So maybe I'm clicking on different buttons in the user interface or loading different files and manually checking that it's working and that it seems correct. This takes up loads of time. And again, we're trying to make maintenance as fast as possible. So the ideal thing is we want to automate this. We want to turn those manual checks that you would normally do into automated tests. The advantage here is now every single time there's a change, I can run these and it is a lot faster. Yeah, framework-wise, there are loads out there. I'd say for Python, so for napari and all of this, PyTest is the most popular one. They have great documentation with a lot of examples. For Java and Fiji, they have JUnit, which again is very fully featured and so on. They are slightly different, but I'd say that once you've used one of these frameworks, they all have very similar features and very similar structure. So once you've learned one, it's a lot easier to learn the other ones. Right, I'm going to show you a very rapid example of a test just so you can see how it works and the general structure of it. Again, it's just to give you a general idea rather than going super deep into it. So this is a Java example. Don't worry if you don't do Java, it's more about showing the structure. I'm going to talk through what it does. Here I'm making a test, so I've tagged it as a test. And what I want to check here is that I can read in Crosshair's settings correctly. So every time I start up Crosshair, which is my plugin, it has to load a bunch of settings from a file. Now, if I was doing this manually, I could manually open the user interface, load the settings, look through the files, check that it's all working, but that all takes time. Instead, I'm going to do it through code. So what I'm doing here is I'm loading in this file, example-block.json, which is my settings file. I'm then using my settings reader to actually read those. And then I'm pulling out a couple of those settings related to planes and images, and then I'm checking that they're correct. So for example, here I'm checking, are there 2 planes? Are they named the right things? You know, they should be named block. and target. Do I have the right number of images, etc.? So all the things I would normally check manually by eye, I'm now doing it directly in my code. The advantage here is that now I can run this. I can let Java think for a bit, and eventually it will say that it's happy with that. Yeah. So in case that's too small to read, you get this green bar and it says tests have passed, and I know that my code is working. If I change something so that it's now going to be unhappy about this, so now I'm saying, hey, are there 3 planes? And there won't be. We let Java think for a bit, and now it should give me a clear indication that it is broken. So here, again, if it's too small to read, it's like a red bar and it says, tests have failed, I expected 2, and I got 3. This is a very simple example, but you can imagine how you can build this up over your whole code base, adding in automated tests for all of the key parts of it. And then every time you make a change, you can run this and you'll get a very clear indicator of does it work or does it not work? And this makes it a lot easier to add new features without being afraid of breaking old ones. So this is a very useful thing to have in here. Just to show that it works for all size, I've got a very brief napari example. So I chose a random BrainGlobe repository. So BrainGlobe, again, is a set of Python packages and napari plugins that's made by the Neuroinformatics unit at the Sainsbury Welcome Centre. I've chosen a random test from BrainRender and napari because it does something very similar to what I was doing just now. So here they're checking that they can read some metadata. So they're reading from an atlas, they're getting out their metadata from it, they're then loading it from a file, and then they're checking that they are the same. So you can see that the syntax is slightly different, but it's a very, very similar structure doing it in Python or doing it in Fiji. Almost all tests will have this general structure of you do some setup, you call the thing, and then you check that it's got the correct result at the end. All right, so here we have some automated tests. Ideally, you would add in a whole bunch that cover all of the important parts of it. But so far, I've only been running them locally. I'm running this on my computer, which is fine, it works, but it relies on me remembering to do that. So if I don't remember to do that, it's very possible for me to add code into, Crosshair, BrainGlobe, whatever, and to break something and for it to remain broken. So ideally, if I go back to my slides again, ideally, we want to run this remotely. So usually every time a pull request is open, so remember this is a request to add code that might be from me or somebody else or from some automated tool like Renovate, Dependabot, etc. I want it to run automatically every time. It means that I don't have to remember to run it. It will make sure it's always run. And this is an example of something known as continuous integration. It's a very general term, but in broad strokes, it means that you want to integrate new code changes frequently and usually with some kind of automated tests or automated builds associated with that. So, every time a pull request is coming in, a bunch of things are happening automatically without us having to manually intervene with it. There are loads of tools to do this. I'd say if you're using GitHub, they have a great system called GitHub Actions that also has very extensive documentation that can let you automate all kinds of different tasks. I'm going to show you an example now, but I would encourage you to look at the documentation. There are a lot of different things it can do. If you're using something else like GitLab, they have an equivalent system as well. So find out which one you're using and find the relevant system there. All right, very quick example of what that looks like then. Yeah, let's do Crosshair. So if I go onto this Actions tab, so I'm back on GitHub now, you can see examples of where I've been running my tests remotely and automatically. So each one of these lines is where it's been running all of my tests. And if it works, it gets this green tick. That means my code is working, everything is good. And if it doesn't work, I get this red cross, and that means that things are broken and I need to do some extra work. So the advantage now is if I have something like this, which I was showing you before, this is this pull request from Renovate where it's telling me, hey, you need to update this version to version 44. If I scroll down a bit, you will see it has also run my tests automatically. And in this case, it has found that they are failing. So I need to go back, do some extra work to make it compatible with these new versions. Again, feels like a simple thing, but this speeds up maintenance so much to be able to automatically know there are changes and then automatically know that there's something wrong that I need to go and fix. Saves so much time versus having to do all of these things manually every time. I'll give a I'll very briefly point to you where those GitHub Actions are set up. But again, there is so much documentation out there, and this is really just to make you aware that this exists and that it's a useful thing rather than going into the details. So under .github/workflows, this is where all of the GitHub Actions information goes. Here I have this one, which is for my tests. And the main parts of this, I'll just pull out a few important bits. It's saying when there's a pull request, so when there's some request from code from me, external, unautomated tool, whatever. It then goes all the way down here and it's saying, please check out my code, which which means that it's gonna make a copy of my code, then set up Java, install some things that it needs, and then build. And this is the part where it's going to run the test. So you can kind of think of it like you set up kind of like a recipe or a series of steps, which then GitHub Actions will go through whenever whenever the trigger happens. So in this case, I'm saying every time there's a pull request, go through this series of steps, please run my tests and so on. And like I was saying, here I'm using it for tests, but this is very, very flexible. So if there are other things that you want to automate, GitHub Actions is the place to go to do that. Okay, so very, very quick example of that, but I'd say automated testing is one of the big things that make it a lot easier to maintain projects and to keep them running for a long time. So do take a look at that. On the theme of testing, something else that you might want to look at is code coverage. So code coverage is a measure of the percentage of source code that is executed by your tests. What that means is, say my code coverage is 20%, it means that only 20% of my code is being run when I run my tests. The reason why this is a useful metric, you can't have good testing without good code coverage. In that example where my coverage is 20%, it means that 80% of my code is never run by my tests. So there's no way that it can tell me if my code is working or broken because it's not even running it. The flip side I want to mention is you can have good coverage with bad testing. So it's a useful thing to look at, but it's not the be all and end all of everything. It's really important when you're writing a test that all of those checks at the bottom there are comprehensive and are properly checking that you're getting the right results. Code coverage just tells you where the lines run. It doesn't tell you, am I properly checking that they're doing what they're supposed to be doing, right? So it's a useful indicator, and it's also useful for pointing out areas of the code that are never being covered by tests where you might want to go in and add some more. All right, so again, very brief example of code coverage then. I'll show you it in this because I already have it open. So I've already run the code coverage because my tests take a bit to run and I didn't want you all having to sit there while I slowly run my tests. Almost all programs that you use for writing software, this is IntelliJ, but like VS Code, PyCharm, whatever, will all have options like this. There'll be an option that says something like run tests with coverage. And when you run that, it will run through all of your tests and it will give you some kind of result like this. If this is a bit small, I'll tell you what it says. So for every single piece of my code, it's telling me the percent of classes that have been covered and then the percent of lines that have been covered. So if I choose one that has bad coverage, like this one, let me make it a bit bigger. What it's giving you is this bar down the side. So first it's telling me that 47% of the lines are covered. So there's a lot of lines that aren't covered here. And whenever there's a green bar, it's saying that line is covered by a test. And whenever there's a red bar, it's saying that isn't covered by a test. So this can help to guide me to where I might want to add more tests to check things are working correctly. Yes, sorry to people who might be colorblind for red-green. They always use red-green for the default, but most tools will let you customize it to be whatever color you want. So yeah, there's normally one color for yes, it was run, and another color for no, it was not run. So this works. All tools will do this. If you're doing Python, Java, whatever, there will be some kind of tool like this to check the coverage. But as I was saying before, like with the testing, this relies on me remembering to run this. So it would be very easy for me to keep on adding lots of code that don't have tests for them, and then gradually having my coverage come down without me noticing if I forget to do this. So it's another thing that we can automate, and we can automate it with GitHub Actions as well. So there's lots of tools for this. One of the popular ones, which I'm going to show a very quick example of, is CodeCov. This is their logo here. Again, they have great documentation. Go have a look. I think I have a quick example. Yeah, I do. I chose a random one. So this is a random pull request from Brain Render, which I mentioned before. I don't know what's in this pull request. I just wanted an example where code cover was running, which you can see here. So somebody opened a pull request to add some extra code, and then CodeCov has automatically, without me having to do anything, come in, run it, and said, hey, the coverage is 97%. And you can set CodeCov up to have certain targets so that, for example, here, if somebody had added loads of code which didn't have tests, then CodeCov could complain and say, okay, you've got to have at least this much coverage, for example, which can be useful for making sure that it is maintained again. It also gives you a nice online summary, which I can show you. So this is similar to what I was showing you locally. You get this sort of green for covered and red for not covered. Here it's all covered, but yeah, you would get a mix of that green and red, which can help you to see where you're currently missing with your tests, which can be quite useful too. Okay, yeah, so common theme here with all of this is most of these things you can do locally, but if you can do them automatically remotely, then it's a good thing to go ahead and do that. Okay, next thing. So I want to talk a bit about releases and versioning because I think this is something that is super important for making it easier to maintain things long term. So I already talked about version control. So version control is very like developer focused, it's tracking every single tiny change that you're making to your code. Releases are much broader, like longer chunks. It'll become clear what I mean in a minute. So basically, a release is every time you make new code available to your users. So as a developer, I might be adding a whole bunch of features. Like maybe I'm adding support for file format 1 and file format 2 and file format 3. I might be working away at that. And so far, I haven't made it available to people who actually use it. Once I'm done adding all of those things, I might be like, okay, I want to make it available now so people can try it out. And that is the point where I would say this is going to be a new version, this is going to be a new release. So for Napari, for example, every time I upload new code to PyPy, make it available to people, that's a release. Or for Fiji, every time you upload to your update site and you make it available to people, that would also be a new release. What I sometimes see people doing is they make a lot of releases, but they don't give them different version numbers. The challenge with that is it makes it hard for you to know what version of code people are using, and it also makes it hard for people who are using it as well. So maybe they've downloaded it on 2 different days. Now it acts differently, surprisingly. You want to make sure that every time you're making changes, it has a new version number so everyone knows there were changes and what those changes were as well, which I'll get to in a minute. Yes. So when you're making releases, give them explicit version numbers. By that, I mean something like this. So you can kind of see in the top right there, they're normally given some format like number dot number dot number. There are a few different schools of thought of how to do this. I've kind of linked to them there if you want to look at them. So two very common ones are semantic versioning and effort-based versioning, I believe it's called. They're reasonably similar in the broad principles. I'd say it doesn't matter which one you use. The main thing is to use it and to be consistent. Both of them work on this similar scheme of 3 numbers, and the first number is for very big changes. So maybe I've added loads of things, or I've changed a whole bunch of stuff. So people will have to make a lot of changes to be able to use it. The middle number is normally for medium-sized changes. Maybe I've changed a few things, and then the last number is for very small changes. So maybe I've fixed a bug, and most people won't even notice that I have made that change. So yeah, normally 3 numbers, and very broad strokes, it's normally big changes for the first number, medium changes for the second number, and small changes for the third number. But I think the main thing is just make sure that you have a different version number every time new code is going out to your users. All right, I will show you a brief example of what that looks like. Let's do a cross because I have it here. So on GitHub again, this is why I mentioned GitHub at the beginning. All of this is very much assuming that you're using this or something similar. There is this releases tab down here. And this is where you can see all of my releases. So the last one was version 1.0.6, for example, but there's also 1.0.5 down here and so on. So there's this history of versions going back in time. And again, you can kind of think of when I'm making a new version, I'm taking that specific point in my code, and it's kind of like I'm putting a flag on it and saying, this is version 1.0.6, and it will always be this specific point, and it's not going to change. Then I make some more changes, and then the next time that's now version 1.0.7. But people can always go backwards and forwards because I'm being consistent with how I do it. And also that every time new code goes out, it gets a new number as well. Okay, so way that you make these in GitHub, you can come up here to draft a new release. Then you can give it a new number. So for example, for me, I could say this is going to be 1.0.7 as my new one. I can say, please create this. I can give it a title. I can have a general description. The thing that I also see a lot of people do is they leave this description empty. And I'd really encourage you not to leave the description empty. I think having versions is already better than having no versions, but having a description, which is normally known as release notes, really, really improves it. So the whole point of release notes is it's trying to describe what you've put in the new release. So what has changed since the last version? And this is really useful for yourself, for one, when you're trying to come back and think, what did I change? What was the last thing that I put out? It's a really useful summary, but it's also really useful for people who are using your software to be able to see exactly what has changed, because it will guide them to what they need to update or new features that they might want to use, etc. So I'd really encourage you put something in this box. The minimum level is if you click generate release notes, GitHub will make a nice basic summary for you. It uses, when I was showing before, Git, like this summary of all of the commits, everybody puts a little description. This gives you a summary based on those descriptions. So it's automatically made, but it at least gives you some idea of what has changed there. And it was very quick to make. It was a one single button push and it was done. So I'd say this is the minimum level. Do something like this. It's really, really quick. And yeah, it's very useful. The next level up from that is ideally you would go in and edit this to help to highlight what the main features were, maybe provide a bit of extra context. And I think I put some examples here. I did, yeah. Napari itself has great release notes. So if you ever want to see some examples of great release notes, go have a look at their GitHub. So here, for example, they're preparing for 0.7.0. And this is a draft of the release notes that they're going to make. And you can see this is super detailed. They've put loads of information about what their main changes were. They have nice summary tables. And if I go down a bit more, they also have like summary images of the things that they've changed and so on. Yours don't have to be as detailed as this, it can be somewhere in the middle, but just to say, ideally you go in and edit it a bit more to make it really clear what you changed and what the most important things are. The other thing I wanted to say is all of these release notes are normally on GitHub or something similar, which is great for developers, but anyone who doesn't do software stuff is very unlikely to ever see them. So it can also be good to put your release notes somewhere else where people who are using your software but who aren't software developers can access them too. So Napari also does this very well. So here we are on the Napari website, and here you see exactly the same release notes, but now it's on their website, nicely formatted, with all the tables and images. So now anyone can come here and read this, even if they're not super familiar with GitHub itself. Napari is also very good at like posting on social media and all of these other things. So they make it really easy to tell when things have changed and what has changed, which is great. There's a lot of pieces of software out there that don't do that, and that really makes things harder. It also makes it harder for you as a developer because people report a bug and you don't know whether you fixed it or whether it was some very old version. You don't know. Okay, so very rapidly, release notes. They're good. Have release notes. They're great. And then I wanted to briefly mention things that weren't code as well. So I feel like as developers, we tend to fixate on the code itself, but there are so many other things that are super important for maintenance. And one of those is documentation. So this is all of the information about how do you use your piece of software, how do you install it, etc. Yeah, like I put here, make it easier for yourself and also for other people to use your code. There's lots of different ways to set up documentation. I'll briefly show a few examples, but yeah, there are lots of different ways to do this. I would say the minimal way, which I'm going to show you now. So this is an example of another project I worked on recently, which is Enigma PD WML. It's for segmenting white matter lesions. If you're interested in that, go look at it. There were lots of very nice researchers that were involved in this. I'm putting this here as an example because here it does like a few specific things that are reasonably simple to explain. So everything is directly in this README file. So this is this readme.md file. When you make something in GitHub, you'll normally get an empty one of these for free. But this is the simplest way to do documentation. You can write out whatever you want, and it can still have nice formatting and diagrams and, step-by-step instructions, but it's all here in one specific file. So I'd say this is the easiest way. At least have a nice description in the README. When it gets more complicated and you have more things to describe, then you might have to step up to something else. I was going to show you quickly how I do it for Crosshair. So in Crosshair, I used GitHub's wiki. So there's like a wiki page here, and this lets you have multiple pages. So like this is my home page, but I don't know, there's a page here for how to set up planes, and you can have images and so on. So I say this is a nice option if you want something quick and fast with multiple pages to go through. The downside of it is it doesn't support like a full pull request workflow like we've just been talking about. So if you have lots of people contributing, it's not ideal. It's probably not something I would use again for another project. But if you have something simple and you want a few different pages, it is there. That's why I wanted to mention it. The final option is, well, there are even more beyond this, but another option that's very common is GitHub Pages. So GitHub can host websites for you for free, and lots of people use this for their documentation. And I'll briefly show you an example of that. So Brain Globe, which I've mentioned a few times, I believe their website is hosted with GitHub Pages. And there's lots of different ways to build these GitHub Pages sites. Here they're using a tool called Sphinx, but again, there are many others. But you can see you can make a really nice fully featured website like this, and it can be hosted freely on GitHub right alongside your code. So it's a really good option. Again, there's loads of documentation, have a look at it. The other reason I wanted to show this was documentation is really important, but it's also really useful to make sure that you provide both user documentation, so for people who are going to be using your tool or your plugin or whatever, but also developer documentation for yourself and also for other developers. So on the user side, it might be something like this. So here they have these nice tutorials where there are examples of how to use their Napari plugin with screenshots, and it's like really step by step, which is really useful. And again, this saves maintenance time because you're not having to answer lots of questions about how to do this. You can point people towards the documentation. But they also have developer documentation. So if I go over here, they have a lot of detailed information here about, for example, how they do their testing or how they publish new releases and etc. And it's all here. So again, it's very useful for yourself. I'm often coming back to code that I haven't touched for 6 months maybe, and like I don't remember what I set it up to use, and having it in one place that I can read is great. It also really helps to encourage other people to contribute. Most of the time we're putting our code out there free and openly available, and in the ideal world, people are working together and adding things, and having explicit documentation for developers is great. It really helps with this and helps to smooth everything along there. What else did I have here? Oh yeah, I wanted to also mention this is one of the things that you can put into GitHub Actions. So you can make it so every time you change your documentation, it automatically updates your website and so on. So just to emphasize again, GitHub Actions is very, very flexible. All right, final thing I wanted to mention is the sort of other side of documentation. So far we've been talking about very high level. So this is all about written tutorials. How do you use a plugin? How do I install it, etc. The flip side of that is the documentation specifically for the code. And here this is very, very fine-grained, like low level. So for every function or every specific class I use, it's detailed information about how to use that specific function or specific class, for example. Normally this is done with a specific format of comment that you put directly in your code. I'm going to show you an example of it in a minute in case you're not familiar with it. So Python has doc strings. There's a lot of different standards out there, which is kind of annoying. The most common one and the one that's normally used for Napari is NumPyDoc style. If you Google NumPyDoc, there's a lot of detailed information about how this is structured. And also a lot of tools can auto-generate the structure of this for you, so you don't have to manually type all of this out. For Java, so Fiji land, there is JavaDoc as well, which is again sort of a standard comment structure for this. All right, brief example of what that looks like. I have too many tabs open now. Yeah, for example, this. Again, don't worry about the details of the code. The point is to show you what the doc string looks like. So this is from Napari. This is their image class. And this bit is the doc string. So you always have this sort of triple quotes for Python. And then you have different sections, things like parameters or results or whatever, with the detailed information about what each one is. So here, for example, they're describing what data could go into this and what affine transforms, etc. This is a massive one. You might have a much simpler function, but I just wanted to show you what it can look like. The advantage of this, it makes it really clear for you what it does. It makes it really clear for other people what it does. And also, if you use these standard structures, like Java doc strings, etc., you can automatically generate documentation for these. I'm just trying to find the link, sorry. For example, here. So if we go to the Napari website now, and we click on image, here is exactly what we were looking at just now. And this has been automatically created from what was in the code. And it has nicely formatted information about everything that's there. People can come here and browse it. It makes it a lot easier for other people to use. So yeah, upshot is do this. It's useful for yourself, but also adding these kind of automatically generated documentation is very useful for other people. And yeah, if you use the standard format, you can get it basically for free. So it's a really useful thing to add. All right, with that, I'm starting to run out of time, so I will do a bit of a summary. So there are loads of things that you can add to help make your project more sustainable long term. There are even more things to this. My presentation was originally a lot longer, and then I realized there was no way I was going to fit it in. So there's loads of different things that you can add. It's a lot, but I would say again, really focus on what has the most impact for your project. So to give an example from Crosshair, for example, when I was making that, I was starting to add automated tests. I was adding them in at the end. I was overwhelmed because I had a whole bunch to add. But first of all, I focused on the most important bit of the software. There was this core algorithm that everything depended on and that I was really afraid of breaking every time I made a change. So I added a test specifically for that. And already that made a huge difference. So you can incrementally build these things up, is what I'm trying to say. The flip side of that is ideally you add them early on. So once you get experienced with all these different tools, it's easier and better to add them in at the beginning, and then you can, it can grow as the main bit of the project grows. So now when I make a new project, I add basically all of these things from day one. It makes it a lot simpler. But I'm aware there are a lot of existing projects out there that you have to add things in after, and there I'd really encourage you focus on what has the most impact originally for your project. Okay, a few quick further resources and then I'm done. So one thing is where I work at Arc, they have this Python tooling website, which can be quite useful. It has examples of different tools for Python and what Arc uses and why. There's also a template for making new Python packages, which can set up a lot of this for you, which is quite useful. There's the Turing Way book, which covers a lot of these concepts. They had to keep it very general because it's for kind of anything. It's not image analysis specific, but it's still quite useful to look at. There's also software carpentry courses. So if you're not familiar with Git, they have an introductory Git course. There's also this intermediate research software development course, which is still in development. It's still in the incubator, but it is very good and covers a lot of this. And yeah, maybe just a final thing to say, I think it would be really useful to have a resource that's specifically for Fiji and Napari plugins that gives like detailed examples of how to set these things up. Yeah, if I ever have time, I'd love to have a go at making something like that. But I think with that, that is kind of everything. So thanks very much. And yeah, happy to answer any questions that people might have.
Fabulous. Thank you, Kimberly. That was such a good talk. So much actionable insight there's, and I really appreciate the resources that you've shared at the end. So we now have about 10 minutes for questions. There is a Q&A tab, so if there's anything that you'd like to ask, you can add it to the Q&A tab. And it's also possible, I believe, for you to raise your hand and then I can allow you to talk. So, okay, we've had one question come in from Alessandro Felder that says, is there a Spec Zero equivalent for Fiji or broader scientific Java? Maybe I missed it.
Yeah, no, this is a good question. As far as I'm aware, no. I would kind of love that. I mean, I think for Fiji, it's a little different because Napari, Napari is trying to be really minimal. It's to some extent. They're trying to just have a few things and then all of the plugins built on top of that. Fiji has a lot of stuff in it already. So the POM SciJava I was showing you is it's kind of that. It's showing you all of the dependencies that are in the current version of Fiji so that you can test against it. The challenge is, yeah, that there isn't really this equivalent of showing you a range of versions to support. And also, it's really hard to tell when Fiji updates and what has changed. This is why I'm on the release notes thing. So Fiji, as far as I can tell, doesn't have release notes. So you never know what has changed. And it comes in at times, which is why Renovate has really been a game changer for me to know, so I can know that Fiji has updated. But yeah, as far as I'm aware, there isn't that equivalent of kind of saying these are the core packages and they change. But because Fiji has a lot of stuff inbuilt, they do have this POM SciJava, which is kind of all of the dependencies that you can check that it works against to make sure that it works in Fiji. So kind of. Yeah.
Lovely. Any further questions from our attendees? I think I can see any hands up. So I have a question, a few different questions. So I wondered whether there were any, whether when you're starting a new project or working with a new team, whether there are any warning signs that come up that a particular project might be difficult to maintain in the future.
Yeah, yeah. I mean, I think Arc, because like I said, we're kind of like a software core facility kind of. We have a lot of projects where we're, maybe there's a piece of software that's been written in a particular group by a PhD student or a postdoc, and then they want us to add something on top of it. So we're regularly being given pieces of software that have been made in other places to build on top of. And yeah, I would say there are some warning signs. So like some of the classic things is I was talking about documentation. Having no documentation is a huge warning sign because often, especially in academia, everybody's moving around and leaving and whatever. So if I'm sure the person who made it, it's probably great and it works perfectly. But if they have moved to Australia and they don't respond to your emails, it doesn't work and that's the end of it. So yeah, not having any documentation is like a huge warning because it makes it take so much longer to tell what it's doing. Not having any doc strings in the code as well. The other classic is having everything in one file or in one massive function. So having like analyze as a function and then it's thousands and thousands of lines long. Like I think I didn't really mention that, but it's really useful to split up what you're writing into separate functions or into separate files. This all makes it way easier to maintain because if I'm looking to add something, rather than having to read the whole massive function, I can go to just the bit that's relevant for me and like just change it in that one place. So yeah, those things are useful. I would also say for the testing side of things, it's really useful to have some tests. And we often come across projects that don't have any tests. And I can understand they take time to add, but equally, the time to add them saves you time with having to do maintenance, or if somebody has to add things, which often happens later. So yeah, I would say not having any tests is often also a red flag that it's going to be a rather challenging to work with. Like I was saying, like I feel like you don't have to immediately try and get 100% coverage, but looking at like what's the most important thing or the thing that I break the most often when I want to add things, adding tests just for those bits is already so great and it's going to make everybody else's lives way easier. So yeah, that that was a few things. Hopefully that answers that. Yeah.
Yeah, thank you. I've seen Martin has popped his video on, so I don't know if Martin's got any questions.
I was going to ask a question that actually the other Martin just asked
Aha.
in the chat, which I can read out. So, how do generative tools fit into this CI/CD setup, such as AI generated code tests and documentation?
Yeah, I will be very upfront and say that I don't use these tools very much, so I can't give a very comprehensive input for this. There are a lot of tools there, and I know, for example, GitHub Copilot is very popular for people for generating code, and it can also suggest reviews as well. In my experience, and I want you to understand that I'm biased, I haven't found it to be super useful in my experience. I find that it tends to focus on the wrong things, and then I end up having to explain why I'm not doing the things that Copilot asked me to do, and then also respond to the person who's asking me to do something. So in my experience, it adds work, but equally, there are lots of people in our department that do use it. So I think it's still in that sort of personal preference land of you can kind of figure out whether it's useful for you or whether it's not. I think the most important thing, especially if you're contributing to an open source project, so you're contributing to someone else's project, maybe you're adding something to, Brain Globe or Napari or something else, is to make sure if you are using these tools that you understand what the code you generated does before you submit a pull request. Because I've heard from a lot of people who are maintaining big projects that these generative tools have made their lives harder as maintainers because they get so many pull requests from people and they are massive, and they go through and they review them and they're asking people, could you refactor this bit, could you change this, but then people struggle to do so because they don't understand what the structure is. So yeah, I'd say you can definitely use these. There are lots of people in our department who use them to great effect, but make sure that you understand what the output is. And it's very likely that you're going to have to do some editing at the end. It might give you a general structure. You can edit a bit and then put it in. But yeah, personally, I don't have loads of experience, so I can't talk about it too much.
That sounds like something that CCP-volumeEM would be well placed to at least support the dialogue on. And yeah, Martin Wynn, who asked the question, this can go across COSEC as well. So all of the other CCPs, I guess, will have similar um, issues, concerns, opportunities. So yeah, I think it could be a good discussion to continue.
Yeah, no, I think it's definitely useful to have some kinds of guidelines and suggestions for how to use it because yeah, they've really exploded in popularity, and you'll find a lot of the documentation that I link to, they'll often have a section where they talk specifically about AI, and I think that's a good thing to put in your documentation. So you might say something like, you're welcome to use it, but make sure you understand, and if we get a huge thing in which doesn't make sense, then we reserve the right to just close it. This sort of thing, like where you just clearly lay out what your opinions are for your specific tool. But yeah, it's still a very much a growing space. It's changing all the time.
Great. I think we have time for one or two more questions if there are any from the audience. I've got my eye on whether any hands going up. Well, I've got another one. So you've touched on it a little bit throughout your talk, but I was wondering whether you could say a little bit more on how the way in which the academic landscape, academic incentives affect good software engineering practices, and whether you feel things are moving in a better direction, what might change to sort of support this kind of work.
Yeah, I think it's a really challenging it's a really challenging kind of problem, because like I was saying that software keeps on needing effort put into it, and grants, they tend to focus on like a specific research question that you're trying to answer, and it's a specific amount of time. And I totally understand that. It makes sense, but it means that we're often incentivized to build software very, very quickly that does the thing and does it at publication. And then maybe even 6 months later, it's really hard to use it. So yeah, I don't know. I think it is moving in the right direction for one. So there have started to be some funding sources specifically for maintenance, which is awesome. So there was recently a Software Sustainability Institute call for the Research Software Maintenance Fund, which is specifically for maintenance, which is awesome. So I think that there should be way more of that. I'd say there's also this general movement for research software engineering, which is what I do and what other people in the department do. There are a lot more places now where there's a core, I say core facility because I feel like in imaging everybody's familiar with imaging facilities, but yeah, there's so many more universities that have like a central place for research software engineering where they have permanent staff. And I think having permanent staff makes a huge difference because you have some continuity. Everybody's coming in and out, PhD students and postdocs or whatever. Having like a central place where you can go for suggestions, or maybe, they're helping you with a project and then later there's another grant and then they're helping you again. I think that is really useful and it does help. it's also fun from a software engineering perspective. Like it's nice to work in a department where everybody's doing software things and you can collaborate, you can work together. Because I feel like academia also often incentivizes this group structure where you have a group, people are doing science things, and then you hire one computational person and you put them over in the corner and you give them every single computational task from the whole lab. And I think that is difficult. It puts a lot of pressure on that one person to support the entirety of the lab. And then often when they leave, everything suddenly falls apart and it's very stressful for everyone. So yeah, I don't know. I think moving to having more of these centralized departments and facilities is a useful thing to have. It's kind of what has also happened on the imaging side with having more of the imaging facilities, and that's been hugely successful. And yeah, hopefully having more grants that on the maintenance side of things would be really useful. But I think part of it is also awareness at all of the different levels, from sort of the grant level and PIs who are running labs, that yeah, software is a continued thing. And if you have a piece of software that you want to keep using in your lab for a long, long time, then you've got to think about who's going to be keeping this going, especially if you're not computational yourself. So yeah, not really an answer. It's a really difficult thing, but I feel like it is starting to move in the right direction. But there are still so many projects that start and then they don't last particularly long. Yeah.
Yeah, a few different things that can be changed there. And I think your point about solitary working is a really interesting one.
Mm.
Well, yeah. Well, it is 31 minutes past the hour, so I think we probably need to wrap up now. So just to say thank you again, Kimberly, for your talk today and for sharing your experiences with us. And thank you to everyone that's joined us this afternoon. We will be having another webinar on the 21st of April. So Dr. Piper Fowler-Wright will be talking about Jupyter notebooks for shareable research outputs. So please visit our website. I think Martin's got his hands raised, so I'll let him.
Yeah, so I was just going to say that I saw at least one more question came through. We'll start a thread on the image.sc website. And so any other questions that people have or think of later, we'll add to that thread and we can discuss there where everyone can see it out in the open.
Lovely. Cool. Well, thank you. Thanks again. Bye bye, everyone.